Why is the spark plug in the wrong place? So I think today is a fine day for making a start on welding a custom header and exhaust system for the Hudson here. And I don't mean buying parts from a catalog and bolting them together. No, I mean building a custom header system from scratch with basic tools like we do here. T-shirt weather today, finally. Spring has started springing here by us, which must mean that in the US, fall must start falling, and yeah, I guess in other places it's just turning into autumn. The exhaust system on this thing is actually quite a big challenge. I can't run the pipes through to the back because my frame is lying on the ground. If I had a 2-post car lift, and I am not blessed with such luxury, then maybe I could look at it from underneath and possibly find a way. But I don't know, looking from here, it just doesn't seem possible. So I'm trying to show you here, it's quite difficult to see, but I'm going to try and explain. This here is one of the frame rails. And that there is a cross member that runs across to the frame rail on the other side. Now that cross member is maybe about an inch off the ground there. So running an exhaust, like a 3-inch exhaust or even a 2-inch pipe on the inside of the frame rail from the engine backwards, there's no space there to go through. And now here I'm looking at this is the outside of the frame rail. That there's the underside of the running board. So even running an exhaust pipe along the outside of the frame rail, it's not possible because look, I've got that support bracket in there for the running board, and then further back here we run into problems with the 4-link and all of that. So this is not really an option either. Well, I guess it's an option to run an exhaust pipe along there, but I don't know, this idea does not work for me. Now, there's one other option. I can run it on the inside of the tunnel there, which would mean I need to enlarge the tunnel, and then I have to deal with all that heat. Nope, don't like it. I have to find another way. So here's what I'm thinking. There's a lot of space on the inside of this fender in this area right here. So why don't we build a header that comes out of the engine and then collects together on the inside, and then we simply exit it somewhere here to come out through the fender. Something like this. We can even give it a bit of a turn here if we want. Yes, I think I like that. That's interesting. Now, I will not be able to buy an off-the-shelf header that can work here. It's quite a specific application. So I need to build something, and I don't have fancy tube benders and everything in that line to build a fancy thing with lots of twists and turns and coils and a collector and all of that stuff. So we're going to have to employ forest engineering techniques to come up with something here. So I think lake style headers is the answer. I've always wanted to try my hand at building a set of those from scratch. Now if you do not know what lake headers look like, here's a picture. That is what I'm going to try and build using my forest engineering techniques. I called in the assistance of modern technology on this one. Not something I normally do. I gave my gasket to the skewed girl at a laser cutting place, and they used their fancy machine to make me this flange from a 10mm 3/8 material. This is beefy, it's not going to go anywhere. I'm sure you could have gone to 8mm, but I'm happy with that. And you have to throw a bit of money, but man, oh man, I tell you, this sure does save a lot of headache and labor and sweat. Making this the old-fashioned way, yeah, that's a lot of work. So here's the materials I'm going to use. This is a piece of 75mm 3-inch tubing. Here I've got, I think this is 1.5" schedule 40 steam pipe. And then I've got these elbows, JIS elbows I think they call them. And I think they are nominal 40mm. And then here I've got a big ass one as well with the same outside diameter as my 3-inch pipe. So yes, I don't know much about pipes and all of that, but these are heavy elbows. They are made to weld onto the schedule 40 pipe. They've got an ID of 40mm and a wall thickness of 4mm. So yeah, not Mickey Mouse stuff. And it's a nice smooth equal bend. Here in my town, the only places that can bend tubing is the exhaust places, and then you get those bends with a reduced diameter and it's light stuff, and I didn't want that. I think this is going to work just great for me. Nice to weld, and it will last a long time with that heavy wall thickness. It would have been nice if the bend was not so tight. Yes, first price would be something with a larger radius, but I have to work with what I can find here, and yeah, it's not the end of the world. Maybe I lose a horsepower or two, but I can just make that up by adding some extra speed holes, man. Yes, and size wise they are a good fit. Here on my flange, actually, yeah, you can't get better than that. That's very nice. Look at that. So my first challenge is going to be to turn this pipe into like a cone, trumpety shape. One side needs to be the full diameter 3 inches 75mm, and then it needs to tape it down to this size, which if I measure it is actually 48mm. Just short of 2 inches if you want to speak in the imperial language. So I need to reduce this to this diameter. So I want to know the circumference of my elbow. Now instead of using clever calculations, I'm just going to use a piece of cardboard and wrap it around it. And then I can just mark it right here where it overlaps. At that point, we can cut it there. If I cut it right there at my mark, we can just test it. Let's just test it again. There we go. That is the exact circumference of my elbow. Let's just think about this again. If I cut a strip of metal the same length as my piece of cardboard and I bend it into a circle, I'm going to end up with a diameter that's the same as the elbow. Same thing here on the end of my 3-inch pipe then. If I remove this section and then bend it together so that this edge and this edge meet, we will end up with a diameter that will match the elbow. So I used the center finder to make a mark on each side of the pipe. I folded my piece of cardboard in half to find the center. So I've got a mark right there. I line up that mark with one of the marks on the pipe, clamped on the piece of cardboard. A piece of angle bar is perfect for drawing a straight center line on the pipe. So I line that up with the other mark that I made there on the end. And now I can draw myself a center line. Next I need to decide on a length of the cone that I want. In my case I'm going to go with 450 millimeters. Right there. A mark right here. Same this side. Next, connect this mark and that mark with a straight line. Yes. And then I must do the same on this side. clamp this side so that it doesn't move. Let's line up that side. There we go. Okay, so at least in theory, if I now cut out this pie-shaped section and bring those edges together, I should end up with a nice cone that tapers down to match the diameter of the elbow exactly. The reality might be a different story. We'll have to see how it works out. I'm going to start by cutting out this whole section and then we take it from there. So now the fun can begin. I'm going to try and squeeze these edges together here in my vise. I'm not sure how this is going to turn out. And what I've done is I've just given it some wooden spacers or liners here, because I'm concerned that the vise will actually maybe make marks in the pipe and dent it. So let's just see if I tighten the vise. Yes, it's moving. So I'm thinking I'm going to have to, well, maybe hammer it a little bit as well. Yes, it's slowly coming together, eh? The trick seems to be to tighten the vise a little bit, then hammer some, tighten, hammer and so on. And just taking it gently and going along easy. I just drilled a relief hole here at the start of the cut. And that seems to be a good thing to do as well. So I'm just going to keep messing with this thing a little bit more. Slowly working my way along. Tightening. Yes, look, the first section here, I've got it together nicely. So between squeezing it with the vise and hammering, and then I've also got this clamp on, and that is also helping to get it together. So I think what I'm going to do is I'm just going to give it a tack here, and then I'm going to slowly work my way along. Yes, like so. So I'm just going to move my piece along a little bit. Oh, and I do have a piece of wood underneath as well, so that when I hammer it, I don't create possible dent marks. So yeah, if I now work my way along, I can tighten up here. Let's see. Yes, going much better and easier than I expected. Now I can feel it's not perfectly round, but I mean if it's slightly oval, that's not going to bother me. I mean I don't think it will hardly make any difference in the end. So I'm not stressed about it. So an important thing I reckon here is that you got to watch it here from the side, so that as you hammer it, you don't end up having some dents here. We want to try and keep this a straight line. So yeah, I'm continuously checking it from this side where my seam is as I hammer to make sure it comes together nicely. I got the whole thing together. Now the end here is not exactly round, which is to be expected, but let's just check our diameter. Hey, that's about as good as you can get, man. So I can just sort this out with a hammer a little bit and get it more round so that we've got a best possible match here. Yeah, I'm laughing now. This is one of those things where you spend way more energy thinking about it than actually doing it. It actually worked out very quick and easy to do this. So I'm happy. I'm just going to get it welded together. Whilst I have no concern about the penetration and strength of these welds, there's not much that can be said about the neatness of welding done by a shaky old man in a forest. I do know that he's pretty good with a grinder though.
20 minutes later.
Now I can cut it off right here. And we ended up with a slightly oval trumpet. I'm happy with that. But to make my life easy, here's what I'm doing. I've tacked in this short piece of pipe here on the flange. So the OD of this is the same as the ID of my elbow. So now this is going to help me locate that elbow very nicely. And then once I've bolted this into place, I can see where I need to cut it. So there you can see I've got my flange bolted on. My little bit of pipe sticking out there. Now I can put my elbow on there, like that. And let me see if I can just get my hands out of the way. There we go. So now it locates very nicely. And I can rotate it. Now I want it. Well, it stays where it needs to be. Same thing right here, little off-cut piece tacked into the end of this length of 2-inch pipe. Right, so I've picked a spot here where I think my exhaust must come out. I'm going to drill a 2-inch hole right here. So we have a hole there. And we have a hole there on the first cylinder. So now essentially I've got to connect these two holes, right? Now I can stick this here through the 2-inch hole. So the other end of this pipe is now located in that hole in the fender. And now if I line it up here, I can see what angle I need to cut this elbow at, so that we can have a nice connection there. So I can just mark this now. Okay, so I took the elbow off to cut it. Some fine tuning with a grinder. And now everything is nicely lined up and looking good. So I think I can tack the elbow to the flange now. Yes. Awkward. Contortion required. I think that'll do it. Let's take this flange off and see what we got, because in there you can see sweet nothing. Okay. Yes, that worked out well, man. So now I just got to remove that little locator piece that I tacked in there. I nearly thought I'd snook it myself. I mean, I break these tacks in there, but then I remembered about Mr. Dremel. A little difficult, yeah. Come on, there we go. Haha. So I've got the flange back on to the engine, and you can just make out that elbow right there. Limited space to see what's going on in here, but we try our best. So my trumpety bit now needs to weld onto that elbow, but I need to extend it to go through that hole in the fender so that I can get this angle correct and all lined up. So this piece of 3-inch pipe will make it long enough to go through the fender and out to the outside. But now I'm not going to weld this on here. What I would like to do is have some flanges right here. Not only will that make it a lot easier to take the whole thing apart again, but it will also allow me to fit a muffler in this section if I want to do that down the line. Maybe I decide it's too loud or something. Yes, so I need to make some flanges to go right there. And because I am not computer numerically controlled, I bolted two together, grinded them nicely, and now I have two matching pairs, one for each side. Busy cleaning up this flange, and look in there. I can see some proper penetration there on that inside of that seam. That's exactly what we want. Okay, lekker man. I've got this sorted. Now I am going to need a gasket to go in here. So I might as well get that done, then it's out of the way. I'm going to make my gasket out of copper sheet. I did it in the past and it's worked very well for me. So let's do it again. So that first circle is the idea of my pipe. And this one is approximately the outside diameter of my flange. So I can now put this on here and center it as fast as I can by eye. And then we can just scribe it to cut it out. Well, as far as I'm concerned, the easiest way to do this is to cut it out roughly with tin snips. Then bolt it between the two steel flanges and use the devil's tool to shape it for a nice perfect fit. I call it the devil's tool because it makes these evil little slivers that get stuck to the barefoot mechanic's feet. And then we have the barefoot mechanic struggling with a, what is this now? It's a 1600 Kent. 1600 Kent, yes. Ford. Correct. You know what Ford stands for, eh? Yes. Found on rubbish dump. Did it come with a built-in oil tray that you can put under the car when you park it on your driveway? Unfortunately not. So yeah, he's scratching on the innards of this little engine. What's going on here? Yeah, couldn't get oil pressure. Couldn't get oil pressure. No oil pressure. No oil pressure. Right, well, have fun. Other than that, it looks fairly good. Okay, well, have fun, eh? Thank you. Oh, yes. I shall occupy myself with other things. Your current endeavors. And if you haven't got a die grinder, a file or a flap disc in the grinder will do the trick as well. Right, let's see how this is going to work out. I enlarged that hole there to 3 inches. So now my contraption should be able to slide in here. Let's see. Ah, yes. So now I can finally line this up here with my elbow and tack it into place. There's not enough space in here for all of us, but what I did was to tack weld the cone onto this elbow, and then I also added these 2 braces to keep everything lined up and in place, because what I want to do now is take this whole contraption out of here and go finish it up on the bench. Well, good thing I put those flanges there on the extended section. Otherwise, I don't think I would have been able to get this thing out of here. Hey, look at that! Starting to look like a lake style header. Now I've just got to stick in some bits of pipe right here. Which, of course, is easier said than done, as it always goes with this kind of custom stuff. So if I stick a piece of pipe there, it would need to angle, and I don't think I like that. You need a little bend right there. trial and error. Let's see how this is going to go together. I think that bottom one is pretty good now. So this needs to go like that. And then this little trick piece goes in there. But, ach no man, now it looks like that piece is too short. Huh. Damn it. I think I'm gonna have to cut another one.
A few inches later.
Too many variables, Duffy. That was the problem. So I tacked on this bottom bend, so I don't have to hold him anymore. And now I cut this piece a little bit longer. And then now let's see how my top piece is going to fit. Very close, eh? Yes, I just got to take off a little bit more. And then I think we're gonna be there.
A few minutes later.
Let's see, yes, that's it. I reckon it's worth spending the time to get these fits as good as possible, because it will make for the best welds. So now I can just bevel grind these edges here, clean everything up a little bit, and then I can glue it together. This is thick walled stuff, eh? 4 millimeters thick, so it's important to grind a bevel edge here to ensure a lacquer weld. A light bulb moment arrived here in my forest shop. Hose clamp here helps to hold this pipe nicely in place on that bend there, so now I can focus all my attention on lining up the top piece. How cool is that? Now the safety inspectors can cry because I'm not wearing a welding helmet, but what they don't know is that I close my eyes when I make the tack, and I've been doing that for years and I'm still here. Yeah, that looks good. I think I'm happy with that. Yes, Duffy, that's what you get for talking nonsense and being clever with your light bulb moments. I forgot to cut the hole here. Hey. So I'm just gonna just mark this, and then I'll have to break the tacks and take it off again. Cut that hole. Yeah. It's not gonna work very well this way. So Mr. Clever had better do something about it. Come on. Right, now I can cut the hole there. I got it nicely cleaned up to just short of that scribe mark. Now it might actually work. At least this bend is tacked in place. And up here I've got the hose clamp holding it for me. So now I can glue it for the second time. Yes, like so. Hose clamp has done its job on this one. I don't need this brace anymore. This is keeping everything in place, so I can take this out now. And then we can do the second one. I got the first one welded and finished. Just easier to do it now before the others are going into place. So now I can do the second one in the same way, except this time I remembered to cut my hole. And I did a other bit of refinement of my technique as well. I first welded on this bend and finished that as well. Easier to do it before it goes in. Man, I tell you, this clamp idea works really well. So I'm just going to use this to ensure that my two pipes are parallel for the sake of aesthetics. Yeah, that looks good. I'm going to weld this one on as well. Last one, and I think I might have discovered the secret to building these things from scratch. But let me make sure about that. I don't want to lie to you. Right, so 4 becomes 1 for the left hand side. Now there's 4 more on the right hand side to take care of. Here on the right hand side, the rusty steering shaft is in the way. So the exit here from the first exhaust port would need to come out and then do a little kind of turn and go below the steering shaft. We need a little kink in the tail here.
Much later.
Hallelujah, freaking Luia. I've got the brother done as well. You'll see how this one for the right hand side I had to get a little kind of kink here, and that is to allow clearance for that steering shaft that sits about here. Now obviously these ones are made from mild steel, so pointless polishing them, but I did want to sculpt them a little bit just to make them look nice. Now, yes, and I think they are ready for a coating of sorts now. Yes, chroming would be quite cool, but that's a big problem for me here in South Africa. The only decent chroming plant is many thousands of kilometers from me, and I've got a waiting list of many months. And I don't know if I'm prepared to go through all of that. I think I will probably just paint them with VHT or something. We'll see. And in the end, chrome don't get you home, man. So here's the arsenal of tools that I used to sculpt them. Angle grinder with a flap disc. This die grinder with selection of TCT bits and sanding gizmos. I used a file, and I ended up with some handwork with the 60 grit paper here and time. Lots and lots of time. And now I know the secret to having a set of these things. In the words of Leonard Cohen, are you hungry for the answer? Are you truly hungry for the answer? The answer to having a set of lake style headers is this. Just go and buy them, man. The dipster is just a sucker for punishment. Don't be like the dipster. Have to make sure that they fit. The one here on the left side is looking good, and here on the right hand side I've got more than a finger's clearance here for my steering shaft, so that's lekker. Yeah, I'm just thinking now, I could be wrong, but this might be the only 39 Hudson in the world that is right hand drive. How they say, the show ain't done until the fat lady has sung. I still got to do my bend here. I just need to decide where to cut it off. think I will call these header extenders. Well, they are done now as well. So what's the deal with this nut that I welded on here then? Aha, that's something that I've been wanting to do for a long time. The spark plug is going to screw right in there, and I think some of you might know where this is heading. So this nut is a M14 by 1.25. That's the common thread size on spark plugs. And then this side here, I've welded on the M10 nut. And then the master plan, way down the line, here where the M10 nut is, we inject some fuel, we ignite it with the spark plug, and flamethrower. So the thread size on a MIG nozzle or MIG tip, the ones I use, is M6, which means I can screw it into a standard M6 extension nut like this one right here. So what I did was to cut an M10 thread on half of the extension nut with a tie nut like you see right here. Now the MIG nozzle can screw in right there like this. Yes. This nozzle now gives me a tiny little hole right there for controlling how much petrol I'm going to be injecting. This one is 0.8 millimeters. You do get smaller ones as well. And when I start with my experimentations down the line, if needed, I can drill it out bigger too. So my little gizmo can now screw in right here. And then we can connect this to a fuel supply line, which means we can now inject petrol or gasoline right here. The exhaust gases will move that fuel spray this away. We've got spark happening here by the spark plug, and boom! So I did give the positioning of my two devices quite a bit of thought, and I figured, well, the spark plug needs to sit close to the outlet of the exhaust so that we can get some oxygen for ignition. If the spark plug sits further in, yeah, remember we've got the exhaust gases flowing out, so if it sits there, we might not have enough oxygen available to get our boom or our flame. And then I also figured it's a good thing to move the point of injection a bit of a distance away. In this case it's maybe, I don't know, 400 millimeters, maybe a little bit less, foot and a bit. And my reasoning for that is that will give me some travel time for that hopefully sort of vaporized fuel spray to mix and expand before it gets ignited. Yeah, we'll have to find out in the future how this is going to work. Maybe you heard those sounds in the background. It's from water bombing choppers flying overhead. The mountains just to the north of us is on fire. And that's what we end up with. We have our spark plug at the exit of the exhaust. There's an HT lead that will go to a coil, and then we'll have some electrics that we'll talk about in the future, so that at the push of a button you will get a continuous spark right there. Then the fuel injection point right there will be connected to a pump fuel supply. And then I will have a manual valve and possibly a solenoid activated valve if I can find one for switching the supply of fuel on and off. Again, something that we'll talk about and see how we do it at some point in the future. Well then, I do believe we have ourselves a custom lake style header here with some tricks. I think my work here is done. I now have to start thinking about blowing this whole truck apart to solve a number of outstanding challenges. Until I see you again, have a lucky one.
Whatever makes you happy, it just depends on